Hello friends, welcome back to my channel. In this video, we are still talking about real analysis, and then we are solving questions from Professor Chido's textbook on real analysis, and we are in chapter 1, exercise 1, and then we have solved from question number 1 to question number 6, and this is question number 7. The link is on the description if you want to watch from question number 1 to question number 6. Now, for us to solve this particular question, we have to take note of some things. Now, look at what they said here. They said that that A and B belongs to R. And you should know that if A and B belongs to R, that, let's say now, for example, if B belongs to R, that means there exists a negative of B that equally belongs to R. Yes, you should take note of this. Very, very important. Okay? Then, such that now, and then we still have that A again belongs to R. If you have that A belongs to R, therefore A minus B will equally belong to R. Yes, they will all belong to R. So another thing you should take note of is that if X is an element of a real number, if X belongs to R, therefore X squared must be greater than or equal to 0. You should take note of this. Once you take note of this now, we can now start the proof. Okay? So let us now prove this. Solution. For question number 1, we can tell them that since they say that A and B belongs to R, okay, that we are going to have that A minus B must equally belong to R is a must. Then that A minus B that is in R, if I square it, it must be greater than or equal to 0 is a must. Okay, it must be positive. Anything squared must be positive. Okay, so now if we open this bracket, we are going to have square the first one to have A squared, multiply the first one and the second one, double it, you have minus 2ab. Square the last one, you have plus what? B squared is equal to, is less than or equal, is greater than or equal to 0. Is greater than or equal to what? 0. Okay, so now if we now add 2ab to both sides, we're going to have A squared plus B squared is greater than or equal to what? 2ab. Okay, we are adding 2ab to both sides. If you add 2ab to this side, it's gone. If you add it to this side, you have this. Okay, so now we are going to divide both sides by 2. If you divide both sides by 2, you are going to be having 1 over 2 into A squared plus B squared, okay, is greater than or equal to, if you divide it by 2, you have AB. So rewriting it, I'm going to see that AB this is pointing at this, so it should be less than or equal to, it should be pointing at this, less than or equal to 1 over 2 into A squared plus B squared. Okay, proved. Question number 1 is proved. So we go to number 2, II of it said that since we know that A and B still belongs to R, okay, so A minus B all squared, in fact, A minus B will still belong to R. A minus B will equally belong to R, okay, and then A minus B, if this now belongs to R, A minus B all squared must be positive, must be greater than or equal to 0. So if we now open the bracket, I'm going to have A squared, square the first one, multiply the first one and the second one, double it, minus 2ab, square the last one, you have plus b squared, must be greater than or equal to 0. So having this now let us add a plus b to both sides. So I have a squared plus b squared, okay, then minus 2ab, then plus a squared plus b squared is greater than or equal to 0 plus a squared plus b squared. Okay, so having this now, we are going to see that, let me take this one to this side. In fact, add 2ab to both sides. Now this plus this will give you 2 into a squared plus b squared, okay, then minus 2ab is greater than or equal to what? A squared plus b squared. Okay, so add 2ab to both sides. I'm going to have that 2 into a squared plus b squared minus 2ab, then plus what? 2ab is greater than or equal to what? A squared plus b squared plus what? 2ab. Now, if you look at it, see that this and this is gone. So I am left with 2 into a squared plus b squared is what? Greater than or equal to what? Now, if you look at this one could be written as a plus b all squared. Yeah, they are the same thing. So now, we're going to divide both sides by 2. If I divide both sides by 2, I'm going to be having, divide this by 2, I have a squared plus b squared is greater than or equal to 1 over 2 into a plus b all squared. So now, so let me write this one first. That is 1 over 2 into a plus b all squared will now be, the arrow is pointing here, so it should be less than or equal to a squared plus b squared. Okay, so that is that, as simple as that. So now you see that for the equality sign, you see that it is when x is 0. If x is 0, equality holds here, because 0 squared is equal to what? 0 squared. That is for equality sign. But for here, equality sign only works when a is equal to b. If a is equal to b, then equality sign works. Look at it. A is equal to b. Let us put it. You have that a being equal to b, that is a into a, should be less than or equal to, sorry, should be equal to 1 over 2 into a squared plus what? A squared again. So this and this is giving me a squared is equal to, this and this is giving me 1 over 2 multiplied by 2a squared. So 2 taking care of 2, you see that a squared is equal to what? A squared. So uh, the equality sign holds if a is equal to b. The same thing is applicable here. The equality sign holds if a is equal to b. So let's put it here. If a is equal to b, I have that 1 over 2 into a plus a all squared must be equal to what? A squared plus a squared again. So I have 1 over 2 into this, and this is giving me, what do we have? A plus a will give you what? 2a all squared is equal to what? 2a squared. 2a squared. So this is what? 1 over 2 into 4a squared is equal to 2a squared. So this take care of this. You see that 2a squared is equal to what? 2a squared. So the equality holds only when a is equal to b. So thank you very much for watching. Please don't forget to like our video, share to your friends, and if you are new to the channel, please subscribe. You can ask your question on the comment section. I will attend to you. May the peace of the Lord be with you. Bye-bye.